G'day team, welcome back to another video. So in the last video I sort of introduced you to plane vectors, alright, so vectors in the plane and the magnitude of them and things like that. So now we're actually going to start looking at algebraic vector operations, okay? Like everything, we're going to start with addition. So consider first geometrically adding vectors. So I've got vector A here with my components A1 and A2, and vector B with B1 and B2. Now A and B vectors can be anything you want. Now over here I've just made vector A 2 and 1 and vector B 1 and 2. So geometrically adding vectors, we are all over. We add tail to tip and then join from the tail of A to the tip of B. Simple stuff. Now, if we are individually looking at just the horizontal translation of both vectors, okay, the whole horizontal translation of A to B is 3 units across with 2 units of A1 and 1 unit of B1. Same thing with the vertical translation, okay, so the base of A, so the tail of A to the tip of B, so we're going up A2 for the A vector and then up 2 units for the B vector, all right? Now, the total horizontal translation is A1 plus B1, and the total vertical translation is A2 plus B2, all right? So that's exactly what I've written here. So notice how the horizontal step for A plus B is A1 plus B1. Notice how the total vertical step for vector A plus vector B is A2 plus B2. So if vector A equals A1, A2 as our components and vector B equals B1, B2 are our components, then vector A plus vector B is equal to A1 plus B1 and then A2 plus B2. So we're just adding corresponding components, okay? It's as simple as that. So quick little example. We've got vector A, vector B, find A plus B. So vector A plus vector B is equal to 3, negative 2 plus 6, 3. And again, we're just adding corresponding elements. So 3 plus 6 is 9. Negative 2 plus 3 is 1. So vector A plus vector B is 9, 1. Simple as that. Algebraic negative vectors, okay? So if vector A has the components A1 and A2, then negative vector A has the components negative A1, negative A2, all right? Just logical, makes sense, move on, all right? Take it as face value. So algebraic vector subtraction. Now, using similar logic to algebraic vector addition, okay? So I'm not going to go through that same diagram and process, but it is exactly the same, okay? If you have vector A has components A1, A2, and vector B has components B1, B2, then vector A take away vector B is equal to A1 take B1 and A2 take B2, all right? So again, pretty much identical to algebraic vector addition, except we have changed the sign to takeaways, all right? So instead of adding signs, they're minus signs. Easy as that. Algebraic scalar multiplication, all right? So if K is any scalar whatsoever and vector A has components A1, A2, then that scalar K multiplied by vector A equals K times the A1 component and K times the A2 component. All right, super simple formula, logical formula, all right. Please have a crack through questions 1 odds, 2 odds, question 3, 4 odds, 5, 6, and 7 odds. May seem like a lot of questions, but super simple stuff. You guys will fly through these questions, all right? In case you missed the chapter, it's in chapter 3E of the Hazy 11 Spec textbook, all right? Good luck with the questions. I will see you guys in the next video.